Hey everyone, it's Mr. G, and a couple of videos ago I asked for suggestions on which videos people would want to see, and one that I saw in the comments that some people suggested or mentioned were BJC videos. So for those that don't know, a couple of years ago, or a few years ago now, I used to teach BJC, which was AP Computer Science Principles in high school, and apparently they've changed the curriculum starting with this year. So some of the video lessons that I made might not correspond to the exact unit or lab number or page numbers that are there. So I figured I'd jump back into the BJC streets and see what's up and see what's going on. We're going to start with Unit 5, Lab 1, Page 1. If you've only been doing Scratch videos and you have no idea what BJC is, I still think it'll be interesting to watch this video and maybe try to understand what's going on in Snap, because it's very similar to Scratch, and maybe you'll get something out of it. And because this is going to be touching on search algorithms and efficiency, I'm going to be making the next few videos about that, about this topic of algorithms and how efficient algorithms can be and how we describe that efficiency. So let's get started with this lab. It says in this lab, you will use two different algorithms to search a list, and you will learn that algorithms are categorized by the time required to run them. On this page, you will modify your number guessing game from Unit 2 to make the computer do the guessing. So step 1 is to click on the picture to load a version of the number guessing game in which you guess a number from 1 to 60. So I'm just going to open it up and we're going to look at it. I mean, Snap is up to version 6.3.7, which is pretty crazy because back when I used it, it was like version 3 or 4 or something like that. Okay, so let's see. This number guessing game, I think I remember doing something like this in the past. Where the computer's pretty much coming up with the secret number and we, the user, have to guess it or have to come up with a strategy to guess it. So I'm thinking of a number from 1 to 60. So let's say, I know an efficient way to do this, but I think someone who might not know will probably guess randomly. They might say something like they start with 42. And it tells it that 42 is too high, so we got to go a little bit lower. Let's go down to 28. 28 is still too high. 15, let's say. 15 is too high, so we know it's below 15. And I think most people would start this off by guessing, basically. Let's go down to 10. 10 is too high. Wow, let's go down to 5. 5 is too low, so it's it's either between 6 or 9 inclusive of both. Let's try 7. 7 is too low, so maybe it's 8 or 9. 8 is correct. So 8 is the correct number, and it took us 1, 2, 3, 4, 5, 6, 7 guesses to guess kind of randomly. I wouldn't say completely randomly because we were, leaving out the numbers that it couldn't be. But let's see. And play a few times, keep track of how many guesses. So I'm not going to play a few times because, you get the game and you could actually check this out yourselves. Step 3 is to develop a strategy that will identify the secret number in no more than 6 guesses. Okay, so I actually don't like that this is step 3. I think step 3 should be, develop a strategy to guess a secret number. So maybe the strategy that you would use every single time. I don't like that they put this condition here that it'll guess the number in no more than 6 guesses, because now you have to start thinking efficiency. And I don't think most people will, that are new to computer science or new to coding will be thinking along those lines initially. So I think instead it should say develop a strategy to identify a secret number and just write down that strategy. And I think that's a good first start. For number 4, it says write down your strategy clearly enough for others to use it to play the game. And then compare your algorithm with another pair of students. So let me think. Should we go with the efficient strategy? We might as well. We might as well go with a very efficient strategy. So one strategy for doing this, the optimal strategy, is to divide and conquer. So what I mean by that is that we're going to take our data set, and we're going to, every single time we make a guess or ask a question, we're going to cut that down in half. We're going to cut down the number of possibilities in half each time. So the way to do that is to basically guess the midpoint and see if that number is too high or too low. And the reason this works is because our numbers are ordered, they're sorted from 1 to 60. So it'll be very easy to just say, okay, is your number 30? And then we know if it's too high or too low. If 30 is too high, then we're going to go down to 15 because 15 is in the middle of at the midpoint. If 30 is too low, then we're going to go to the other midpoint. We're going to go to 45 because we're going to look between 30 and 60. So that is the strategy that I'm going to describe, or that I just described. Basically, guess the midpoint. The number that we're going to guess is going to be at the midpoint. So if we have 60 numbers here, we're going to, after our first guess, we've narrowed it down to 30 numbers that are potentially the right or the secret number. But we should be able to guess it in about 6 guesses every single time using this search algorithm. And I called it divide and conquer, but it's also known as the binary search algorithm if you want to Google it or see how that works. So that is going to be our strategy. That's going to be the strategy that we're eventually going to code. And I know that I do have a video on binary search algorithms that I'm going to link up in the card above. So if you want to see how to implement that strategy or how to think about it and actually write the code for that, I'm going to put that above. But for now, I'm just going to leave it at that. I think I've done a decent job of describing it. And I guess it'll be up to you to continue on and hopefully eventually make that strategy or implement it in code. And with that, I will see you on page 2. Bye for now.